now I'm going to start the official welcome. As you can see from my screen, this is the panel on the future of communications, sponsored by the NETS virtual organization. That's our cool logo there. And the NETS virtual organization is sponsored by NSF. And we will be rolling out a new website this fall. So it's a one-stop shop for NETS researchers. And so a few housekeeping here. Please mute yourself during the panel presentation unless you're on the panel. And you can ask questions in the chat or message Ms. Tanya Pham, who I will introduce in just a minute, who's my co-host here. We may not answer your particular question because there's a fair number of you, but we will try and incorporate similar questions into one question. So we will try to get to it. We may call on you to ask the question directly, in which case, please unmute yourself. And this meeting is being recorded, so be aware. All right, so introductions. So I'm Katie Wilson. I'm a professor at Santa Clara University, and Tanya Pham is my able co-host, and she is a student at Santa Clara University. And this presentation is part of what we call the Sally Floyd channel, which is webinars in honor of the pioneering telecommunications researcher, Sally Floyd. And now let me get to our panel, introducing them very quickly. So we have a stellar panel today. I'm excited. We have John Cioffi from, sorry, I'm multiplexing here, from who just waved his hand, from ASSIA Inc. and Stanford University. Monisha Ghosh, who is the former CTO of the Federal Communications Commission. She's at the University of Chicago and will be going to the University of Notre Dame soon. We have Tom Marzetta, formerly at Bell Labs, now at NYU, and Ronaldo Valenzuela, last but not least, from Nokia Bell Labs. So I'm going to stop sharing my screen. And with that, I'm going to, there you are, John. I'm going to call on you and ask each of the panelists to just sort of do a brief 5-minute introduction.
Okay, well, hello everyone. I'm John Cioffi. As Katie mentioned, been at Stanford for many decades, now more part-time, but also with a company called ASSIA Inc., which is in the communications space. I love transmission stuff, modulation, physical layer, and have spent most of my career in that. And I understand there's a bunch of questions on the panel today for us to consider in that area, and happy to speak to you all on that subject.
Okay, so with that, I will hand it over to Monisha Ghosh.
Thanks, Katie. Very happy to be on the panel today. I am at the University of Chicago until December, and I started at the University of Notre Dame and the Wireless Institute in January. Just recently finished up a term at the Federal Communications Commission. And prior to that, I was at NSF. And prior to that, I spent most of my career in industry. One of the things I noticed in common among all of us today is we've all had some connection with Bell Labs at some point in our careers, even if it's been short. I think, John, maybe you too, I'm not sure, but at least I know that Ronaldo and Tom and I have. Like John, I have cut my teeth on the physical layer. Most of my initial work was on modulation, encoding, and equalization and OFDM. But as I have stayed in this field longer, I've come to realize that the PHY layer is the most powerful when it is enmeshed truly within all of the other layers. And we'll, I'm sure, have a nice discussion on that on the rest of the panel. Over to you, Katie.
Okay, thanks, Monisha. And now I'm going to hand it over to Tom Marzetta. So, Tom.
First of all, thank you, Katie, for including me on the panel. I spent 39 years in industry before I joined NYU 4 years ago. I began in petroleum exploration and learned very quickly how little I really knew about Fourier transforms when I met wave propagation, elastic wave propagation, electromagnetic propagation experts. I spent, how long? 9 years there, and then 8 years in defense industry, and then remaining years at Bell Labs. And I was very fortunate when I joined Bell Labs in 1995 to meet my very first day, Jerry Foschini, who told me about what we now call point-to-point MIMO, multiple input, multiple output antenna communications. And I thought this was the supremely great invention. And so I spent really all the time since then virtually on multiple antenna communications. Most recently, I've thought that we need to get more physics into our communication theory. So the sort of research my group does, I call physics-based communications. And it's an exciting field to be in. Let me stop here.
All right, so I'm going to turn it over to Ronaldo. And Ronaldo, if you want to share your screen, you can do that to show your slides.
Share my slides or okay.
Yeah, you don't have to.
We're
But
not going. This is just introductions, right? This is
just introductions. Yeah.
Okay. So I don't want to. You're seeing me, right?
Yes. Yes.
Okay. So let's just do that. And hi, Katie. Thank you for inviting me. Hi, everyone. Welcome to the panel. I hope we have fun. I am trying to keep it brief so we save time for interaction, which is usually much more rewarding than talking heads. I'm Ronaldo Valenzuela. I have been with Bell Labs for a while now. It feels like very short, but it's been a while. And when I joined Bell Labs, I had just finished PhD on signal processing, digital filters, and the like. And in the best Bell Labs style, I dived into a problem I knew nothing about that had to do with the propagation at gigahertz indoors. And ever since, I've discovered that that's what keeps you going, to always be looking for exciting problems and pushing the boundaries of knowledge base. And then move on from propagation and modeling to ray tracing to MIMO. And now all of a sudden back into propagation with all the exciting new frontiers of higher bands and mid bands and lower bands. All of a sudden, tremendous excitement going on in multiple antennas as well as a new spectrum, locales.
Great. Okay, so before we start into some questions, we have some questions we discussed, and then we'll get questions from the audience. Does anybody have any statements they want to make on this topic, sort of this crystal ball topic? Or you can wait on that and I can start asking some questions. Oh, there we go.
Can we ask a question?
Hi, Murat. Yes, you can. In the future, though, the housekeeping rules are you ask the questions in the chat because we have a few questions first, but yes, go ahead.
Sorry about that.
That's all right.
I missed that part of the instructions. It's somewhat a light question, maybe a controversial question. The pronunciation of MIMO or MIMO or some other way. What would be the right way to pronounce it?
Good question.
I've always done it MIMO, but I don't know. Ronaldo, what do you call it?
I will turn back the question to the person asking the question and ask him, do you say potato or potato?
I think we're trying to find MIMO here.
I'm a MIMO person.
Finding MIMO.
Finding MIMO, right?
Tomato, tomato.
Tomato, tomato. Okay, that's a
right. Such distinction. No, it's clear enough. Thank you.
Okay, so if you have questions, put them in the chat and then we can call on you. And so that way, because there's a fair number of folks here, so I appreciate it. Thank you, Murat. Okay, I'm going to open it up to, for years, people have been saying the physical layer is dead. And so what does the panel think about that?
It better not be dead or we're in big trouble.
Let me start with that one because I've been hearing it for a long time and I have heard it. It died a few times during the course of my involvement in the career. And yes, I was at Bell Labs a long time ago, like many of you. But I like to tell young people in the area, and it's kind of a play here a little bit, but if you go back to the first book in the Bible, Genesis, and you look at what God did, there's the first step is he created the heaven and the earth. And then he said, let there be light, right? And we all know light is an electromagnetic wave. And it's what we use to communicate. So it's basically the first thing he gave to the earth. And we're trying to be the custodians, trying to be good custodians of that. And there would be no communication. There'd be pretty much no anything without that basic tool. And it cycles many times, but it's a great and honor for us to work in that area. So no, I don't think it's dead. And it's almost like saying what the patent office guy said back in the 1800s, right? No more new inventions because they've all been invented already.
That's right.
We'll claim something as fundamental as this dead. So no, I don't think so. And I think the most recent examples are the XHAL Split 7.2. If you haven't heard about that, that's basically doing all the physical layer stuff and software at the mobile edge of the network. And it is just a booming area, and the government's putting a lot of money into it, and companies are reorganizing towards it and so forth. So it does cycle though. And fortunately, we're heading back into a positive cycle on this area. So that's my input to your first question, Katie.
Okay, anybody else want to jump in there?
Monisha, you go first.
Oh, thanks, Ronaldo. Yeah, so as John mentioned, it's died and revived a bunch of times. But I do think, on a more serious note, I think the physical layer at one time was the most important, the first thing that one did when one designed a communication system. And so a lot of attention was placed on designing it right, getting to capacity, and making sure this one link worked to the best way that we knew how. I think networks today have evolved to become these complex beasts that, while the physical layer is, of course, still extremely important, I think what is really interesting into what is happening now is how the physical and the MAC layer and the applications are all being adapted together. We've talked about cross-layer optimization for a very long time in this community. But I think at this point, as John referred to, with the softwareization of the physical layer, with things like Open RAN coming into the picture, I think there's a lot more flexibility actually that the physical layer offers us today that did not exist in the past. And when we talk about the physical layer, we should also look at some of the very recent innovations that we take for granted, right? Like OFDM, I guess OFDM is not recent anymore, or LDPC. They had their roots back in the 60s. And it took a while for the technology to actually make these physical layer concepts work to mature before they could actually find their way into product. So there is a big time lag between an idea and inception and for it to actually find its way into a deployed system. And sometimes when people see this, they think, oh, it's dead because all these ideas that we invented are not there. I don't see them in any system right now. And so there has to be this time horizon that we are cognizant about when we're talking, especially about physical layer implementations. I have a lot more to say on this topic, but I'll let Ronaldo step in there.
Okay.
Yeah, a lot of thoughts, and I even participated on a paper. I think it ended up being a Com magazine paper, and tried to strongly advocate that it wasn't dead. But apparently, I did such a poor job that people thought the paper was signaling the opposite. But in any case, we had a variety of views. My views are very strong on the topic, and if we expand from the very narrow view of thinking that physical layer means modulation and coding, and it's so easy to say, we're with 3 dB of channel, so end of story. That's such a narrow view. We continue to experiment on new frontiers, on layer 0, if you will, of new spectrum areas to explore, whether it's millimeter wave, sub-terahertz, or even at the lower, super long range at 600 megahertz. And so this very rapid experimentation with new bands provokes all sorts of chain reactions in the air interface. So if you expand L1, physical layer to say L1, then it's very important, little anecdotal tidbits, and then I'll shut up not to monopolize the time. It's very interesting to see that signal processing is way ahead of what gets implemented today. And this is being over the last 30 years, I've always seen this. Why? Because the microelectronics, even though improves at a gigantic rate, cannot keep up with what engineers are able or want to implement. So if we're doing 10 megahertz channels with 2 antennas, oh, sorry, it cannot do 4 antennas because the silicon cannot cope. And of course, there's an envelope of cost and power consumption and everything else, but under reasonable assumptions, the bottleneck is the physical layer. So what can we say is dead? It drives the next generation of every product. I'm talking maybe narrow-minded cellular communications here, which nonetheless is something like $1 trillion revenue per year industry. So it's pretty important when it comes to wireless. So if you think of wireless as cellular, think of cellular as L1. And then, of course, you can do all sort of fancy, nice things on software and et cetera, et cetera. The other way around, it doesn't work. You can have all the software in the world. You're not going to have software antennas, and you're really not going to have software heavy-duty L1 processing. Think of 800 megahertz, 400 simultaneous users, 128 antennas, and boy, that signal processing and baseband digital, whether it's ASIC or whatever it is, it gets really demanding. And the best minds in the field are every year trying to come up with the next generation silicon. So it's cutting edge. It what's drive the business. How can it be dead?
That's wonderful. And Tom, do you have anything to add to that?
Sure. I think points are very good that my fellow panelists made, but I think there's a huge case still to be made for good old-fashioned throughput improvements at the physical layer. And these aren't, again, quoting Ronaldo, this isn't going to come from software necessarily. Just looking at some of the new things that are going to come along, the world is going to be looking and is looking for the next level of human-to-human communications. We've had video telephony now for what, 5 years or more? That came with 4G, and 5G for the person on the street hasn't really brought any new tangibly different experiences. So people are going to want things like holographic video, ubiquitous augmented reality, and this pushes throughputs per users into the gigabit per second range. We aren't going to get this with any 5G technology. Mm-hmm. And so we need real innovation at the physical layer. That's the only place you can look for this.
Okay,
can I do
yes,
a little bit of response, Katie? So I think Ronaldo and Tom, your points are well taken, but let me push back a little bit into the throughput and that the physical layer is the only way that you will get the throughput. Yes, of course, you cannot increase the throughput of a network beyond what a single link can provide. But today, in today's networks, and that's, as Ronaldo said, it's very much a function of the limitations we have in our devices and our silicon today. It is not what you can do with the physical layer. The limitations are coming from much higher in the stack. And if we continue to look at the physical layer in isolation from the rest of the stuff that's surrounding it. So Tom, you mentioned holographic and ubiquitous and gigabits per second. So you have to ask yourself, what is this end user device that people are going to be using when they're accessing these services? If it is going to be a smartphone, which is what pretty much everybody is using, or something of this form factor, we have done measurements which show that yes, we can get 2.5 gigabits per second on a phone today, when, as Ronaldo mentioned, you have 8 millimeter wave carriers being aggregated over 800 megahertz. But you know what? That throughput lasts for 5 seconds because the phone heats up so much that you cannot continue to receive that throughput any longer. And so the question really comes up is that how do we look at the end-to-end system and then see what is it that the physical layer needs to do to accommodate the end-to-end user needs? So there's a lot of attention being placed on green energy at the base station and trying to do things more power efficiently there. But my personal feeling is that not enough has been paid to the limitations that you face on the device end. What uses a network that is capable of 100 gigabits per second if the devices you have can only do 500 megabits per second? So
I'd like to follow that point a little more deeply on the end user devices, because I think when we go to the physical layer, it's not a single link anymore. There's a lot of users that share that spectrum. And there's some questions actually in the chat box. I responded to one of them about the dynamics of how that's allocated. And there still remain a lot of unsolved problems in that area. And that relates to the upper layers and how things are scheduled and timed. And I think in addition to energy, there's also latency. So the response time on things, and theories that allow the capabilities to share, all those users. And in fact, some people tell you massive MIMO will solve the problem. It doesn't, unless you have less things than you have antennas. But the minute the number of things, and you can show this fundamentally, once the number of things starts to exceed the number of antennas, and that's pretty much always going to happen, we're not even doing the right things anymore in 4G and 5G. Those designs and how the modulation and how things are accessing aren't anywhere close to the optimums, the kind of equivalent of the Shannon capacity regions and so forth for these systems. There's still plenty to be done. It's just that new challenges come up with lots more users, or maybe users with larger bandwidth, and trying to do that energy efficiently, but also doing it with a delay that's acceptable. 5 seconds is a problem not only for the energy, but also if things are being delayed that long, of course, that takes some applications into a range where they become useless. So many challenges across the breadth of all of these things.
A quick follow-up, since we seem to have established that the physical layer is not dead, although this panel is perhaps biased in favor of that, by no means it implies that any of the other layers are dead. In fact, I personally, it's not my field, but I personally feel that the progress on the end-to-end and the user experience that is ultimate cross-layer, it's been falling behind dramatically. I don't know about you guys, but the more devices we have, the more modalities of communication we have, the more it seems to be a disaster. There was one of those big consultant groups discovered that the worst car feature from a user experience was the smartphone to car connection, because it never works, it drops, it Bluetooth, it thinks you want to connect to the wireless speaker in the house while you're actually in the car. When you get back to the car, it thinks you're still in the car, and in the meantime, the connection has dropped 5 times, and you need to go back to the site and try to reestablish the music connection. It's a disaster. So what are these guys doing end-to-end end user satisfaction? So yeah, physical aid is not dead, but we need improvements all across.
Anything more people want to say about that? All right, well, that leads into a question from Murat, which I'm going to stick to the physical layer and then go up to spectrum management a bit. And that is, what do you all think about intelligent reflective surfaces as part of the PHY layer?
Oh, that's a favorite of mine. So it splits in 2 camps. If you go to any university electromagnetics department, if they still have one, they're going to be all excited about it and publishing papers like there is no tomorrow. Then take a step back and think as a serious industrialist, and your mission is to deploy a system that is going to serve 100 million users, literally, in the USA. We have 2 providers do that. And think of the geographical area where you are suggesting you're going to go there and you're significantly going to modify nature by adding some man-made something or another. I think the thought just boggles the mind.
Mm.
Now, it can be indeed be used in some niche applications if you want to, illuminate a flashlight into an alley of electromagnetic. Absolutely, but I cannot imagine that there would be a significant modification to electromagnetics of a wide area networks.
Okay. Anybody else want to discuss? And there was another question related to IRS is from Hannah Boguk. Hannah, I'm going to mess up your last name, but Hannah Boguka, who's a wonderful person. And how does IRS compete with MIMO, for instance? So I'm going to add that to the mix a bit.
Okay, let me try that one. I think you need to answer that question from 2 different points of view. One is if you switch from a phased array, an active phased array, to an intelligent reflecting surface, does it enable fundamentally any new capabilities you could not do just with the phased array alone? The other question is, if you replace an intelligent reflecting, or a phased array with an intelligent reflecting surface, are there economic advantages, implementational advantages? So these are two completely different questions. And I think the answer to the first question is no. Anything that you could do with an intelligent reflecting surface, you could do with an active phased array of equal size. It isn't opening up anything new at all, as far as I can see fundamentally. But there could be big advantages as you get up to terahertz, because in order to maintain your SNR as you shorten wavelength, you have to maintain a constant power aperture product. That means that the physical size of your transmitting antenna array, or whatever it is at the base station, has to be the same. It either has to be a very precisely steered mechanical dish, or it has to be a phased array of some sort, with the number of antennas increasing with the square of carrier frequency. Very expensive. So I think that intelligent reflecting surfaces or that ilk might be of use in terahertz.
So quick follow-up. I was taking the question to mean, in addition to whatever you have at base stations, you go around the city, the urban, suburban, if you can possibly conceive that, and you're installing some physical hardware attached to walls of buildings, trunk of trees, I don't know. And in so doing, you're trying to impact the propagation channel of that nature gave you. So if it's collocated with the base station, then I totally agree with Tom. The aperture defines everything, and a full digital phase array is already making full use of magnitude and phase control per element. So you can do to your hard contents anything that the RISC would do if it's collocated at the base station.
Any other comments on intelligent reflective surfaces?
Monisha can go first.
Oh, thanks, John. Yeah, just to add to this, I think, again, and as somebody who at NSF actually funded a number of projects in this area, I think here again, we're running into the question of what works for a single user, single link, may not work for multiple users, multiple links. And I cannot think of too many, at least consumer systems, where you're the only user in the system. The degree of adaptivity and control you need to have on an intelligent reflective surface, where you have hundreds of cellular users in an area and not just one, to me is just something. Maybe one day it is possible that we'll be able to control these remote surfaces, these surfaces remotely, to simultaneously service a number of users, all of which have a different channel with respect to this new thing that you've created to change the channel. But it is definitely, it in my mind is one of those things that are nice to study for a longer term application. I don't see this coming into play right now because people are not looking at the multiple user context when they think of intelligent reflective services. It's always in the case of a single user, single transmitter, single receiver. How do I modify the channel to benefit me?
I would only add to this is that maybe rule number one for communications is know your channel. I like to say that in the classes at Stanford I taught. And when you have the opportunity for the intelligent reflecting surface to change the channel, in this case, the matrix channel, either single user or especially multi-user, as Monisha notes, you're trying to create what they used to call rich scattering, a lot of different paths. And I like to look at that as you take it down to a basic math problem, you're doing singular value decomposition of the channel. And how many zeroed singular values do you have? And you'd like to have many values that are non-zero, and the intelligent reflecting surfaces can increase that number, can make the channel richer, if you will, and create more opportunities to service either the many users or the one users with all those. That is, of course, I agree with Ronaldo, that's away from the transmitter where you're doing that, but you're just getting a better channel. And there's a lot of different ways to get better channels, go at higher frequencies, go other way. But rule number one is, try to have a at least understand the channel. But in this case, you get a chance to improve it as well. So I think there's some opportunity there.
Yeah, another quick comment. I always think of risk in the near term most attractive if it's nearly passive. So think of a city and you're trying to banish this sun shadows by sticking mirrors around. You're going to spend a lot of money in mirrors. And that is what passive, non-adaptive risk would have to do. Now, the minute you go into fully adaptive, and certainly I agree with the points about multi-user fully adaptive with full channel state, then it's really a relay. And relay has been struggling together with small cells. So whether you get rid of the network connection or not, still relays of small cells are dead in the water because they're economics. So it may not be popular in academia, but the minute you want to attach anything, whether it's a RIS, a relay, or a small cell to anything, that anything is owned by some entity or somebody. And that entity is going to want to cut off your revenue. And it doesn't matter whether it consumes power or it's small or big. They're going to look at your revenues and they're going to divide by the number of such things, and they're going to say it's $500 a month, which is not far from what it is. And so the economics are not really helping the hyper-densification. Remember, it's a concept that goes back 50 years. We can do cell splitting. Well, cell splitting has run its course. We're down in downtown main cities, 100 to 100 intersite distance, and it's not getting any smaller. And you know what I learned with the 28 gigahertz, trying to do real measurements from what intended to be very realistic sites, is that the vendors, the tier 1 vendors, told us, you can place it anywhere as long as it's on an existing site, because we're not building any new ones.
Mm.
Although I have a question as a follow-up to what you said, if you accept this premise that small cells and cell splitting are dead, isn't that what is perennially called for to solve the blockage problem at millimeter and the anticipated much greater blockage problem at terahertz?
Well, the reality of the market is telling you that it's not, right? I mean, we have all the way back to WiGig, we have 60 gigahertz. Of course, that's another set of questions but from the propagation is there. So millimeter wave has been around in 3GPP, so high grade, licensed spectrum, no interference, everything else is commercial for at least 2 years. And it has been deployed on existing sites. So they has not gone together. So some people said, because millimeter wave, you will have to have densification. That's backwards. You will have densification in the manner that the market allows for it, and it doesn't.
So if I may just respond to what you said, Ronaldo, and we've done a lot of measurements in Chicago, and we are seeing a lot of dense millimeter wave deployments on new infrastructure. So for example, Verizon has deployed millimeter wave, like 6 base stations in the middle of a field on lamppost, 0.1 square kilometers. But this is, I think, they're targeting certain areas where they think they will have a big density of users that they have to manage.
Where the market allows.
Yeah. And so there, the economics, I guess, works out. But I agree, the economics are there. But then that brings up the question is if we are really not going to be densifying more, and maybe this is a question further down for the panel, is that how are we thinking about, say, millimeter wave as a standalone cellular technology, or even terahertz, as many people are talking about terahertz as the new 6G band. How in your mind does that work out?
Well, these are very, very good questions. And I think we need to start going away from the cellular concept of one solution fits all. I think millimeter wave is a perfect fit for what you started saying. Areas where you have intense traffic demands, like Times Square, Manhattan, or Chicago waterfront, or certainly sport arenas are right now they're being equipped with super dense millimeter wave. So those are going to continue because the revenue justifies it, but it's not going to be widespread regardless of traffic intensity. And I think this is going into the future, talks about future communications. I think we need to ask ourselves the question and not be on denial. If we go to frequencies even higher, then we really cannot suggest that this is something that's going to be deployed wide area for cars, pedestrians. We know 80% of calls or internet sessions are indoors. So are we going to try and serve people indoors? That doesn't even, it's not even possible at 28, let alone 60 or 140 gigahertz.
That leads to a question from the audience, Sri Ananda, about going to even UV and beyond UV and optical, that sort of, optical and UV and that sort of thing. What do you all think about that?
Well, optical works terrific on fiber.
What about optical wireless?
Well, it just makes the point. I'm John probably remembers. I think remember Tera Beam. So you can do free space optics, and you can get your telescopes out there. And engineers have a ball trying to do adaptive optics, and and yes, and then you discover that around 50 to 60% of buildings are in the shadow of another building.
Yeah.
So if your business case can survive telling 50% of your addressable market that they cannot have it, then it's okay. And I think, again, realities of the market, we don't hear too much about point-to-point city, building top to building top free space optics. Technology is there, but it's a niche.
Oh,
There is Wi-Fi, which has been deployed, but that's more of an indoor, in-room technology, which works fine.
I don't think we should minimize indoor, whether it's Wi-Fi, Li-Fi, Bluetooth, or even 5G, and sometimes riding on the wires in one way or another until it gets inside the home, and then there's a wireless distribution problem. And the Wi-Fi, which is largely indoors, I know there's some outdoor Wi-Fi, but that's 90% of the internet traffic today is carried on Wi-Fi. So. And there may be techniques that are better suited at higher frequencies indoor, where some of these problems may not be an issue. Of course, walls are an issue, but finding ways around all these problems, there's still plenty of challenges left for the mesh of indoor communications, even though maybe some of the outdoor problems would not go. And yes, I do recall, and there have been many companies, Ronaldo, that have kind of probably wasted close to $1 billion of venture capital money on free space optics. Unfortunately, a lot of people keep trying it, but in fact, I was on the board of directors of one of those companies. But we should never say never on these things. There are creative ideas, aggregation, failover systems, so forth for it. And if you told me. When I first started, I hate these dates me, but we were trying to get 4.8 kilobits per second over a phone line back then, and now we have 4.8 terabits per second communication systems, and we're using frequencies at much higher, and that's just over the course of one person's career.
Yeah.
If you think about it, we went up, I think that's 1 billion times in terms of the data rate. So we even outpaced probably Moore's law. On that. So I've never seen the data needs and the bandwidth needs go down. Sometimes it flattens off for a while, but then it starts going up again. And we shouldn't underestimate the creativity and uses. And all of these things will eventually have their place. The question is, when is it too early? And also, of course, when is it too late on
Very good point, John. I would add to it that the question is not whether physical layer is dead or not. The question is that the excitement, and I want to be back to positive, no point in going to the long list of things that may not work outdoors. The excitement is really moving indoors. And I think we all have a teaser. If you have a hobby or want to fix something, you go on YouTube and it tells you how to do it. But it's so primitive. I mean, you have to go back to the computer, look at another few seconds of the video. Then how about AR goggles that are really light and comfortable and unobtrusive? And as you're doing your project, whether it's you're fixing your lawnmower or you're doing a new quilt or whatever it is, you are getting video, high quality, of course, high quality audio, and it's guiding you through, or maybe you are participating in a group activity of building something, writing something, or art, or some people say music. I think we can all see that around the horizon. And to be short, there is a lot of excitement, and it might not be along the classical technologies. We need a mindset change, and maybe what we need is move from the outdoors to indoors.
Yeah.
In short.
Tom or Monisha, anything to contribute to that?
No, I agree with you, Ronaldo, and that is where I think we need to, as a community, stop drawing these distinctions between Wi-Fi and cellular and start thinking about what is it that the end user needs and what is the best network to satisfy your application at the time and place that you are at. And again, moving away for a moment to the question of the physical layer and talking about the future of communications in a more broader context, I think that is where we should be looking at more generally. Unfortunately, I think the commercial world that we live in today is still very much divided in the world of standards and the world of products into the unlicensed and licensed space. And I think that needs to change. I think we have to become much better, and it sort of ties into one of the questions I'm seeing on this chat, as to much better dynamic usage of spectrum across all kinds, not just one kind of spectrum.
Okay, so that actually leads me to asking about that question that's in the chat about spectrum management and spectrum sharing. And the Gary Minden says it was a hot topic. What's its current status and state of the art in spectrum management?
Well,
So
go
ahead, John.
I did write a response to that, so I'll read it for everyone. There remain several physical layer unsolved problems in DSM still, and indeed created many opportunities for improvement. So, there's been progress in the multi-user area, but anyone who says it's dead, I just taught a course at Stanford in the spring quarter, and we must have found at least a dozen new problems that are there. So maybe sometimes one path to research gets a little bit exhausted, or maybe the individuals in that area get a little bit exhausted, but there's still a lot of things to be done and huge gains to be had. We're nowhere close to the fundamental limits for a multi-user system and in general today. So, and that will be part of it, these dynamic techniques, and probably using artificial intelligence, because some of the even the known problems and how to solve them are NP hard from a computational standpoint. That gets into one of the other questions there that someone asked about cloudifying the PHY layer. Indeed, that is what the XHAL methods are doing in 5G Open RAN, is this so-called split 7.2. Essentially just the antennas and the D to A converters are out physically at the end, and everything else in signal processing is being done at the mobile edge in a large computing system there. So basically, if you call that the cloud, that's kind of maybe stretching the cloud a little bit, but it's certainly not in the device in those types of architectures. And Wi-Fi can go to something like that as well. So I think it is being cloudified, and we'll see that increasingly used in practice over the next 5 to 10 years.
Tom or Monisha?
Yeah, I mean, this is one of my pet topics, and especially given the time I spent at the FCC, where obviously I was involved in a lot of spectrum matters. I think we're just scratching the surface of spectrum sharing. It has been cognitive radio and dynamic spectrum access has been a hot topic in the research community for more than 20 years. True, but I think that part of the issue with a lot of the work that was done was it was done in a little bit of a vacuum. There were a lot of these situations that were created of primary user and secondary user, very theoretical situations, and then people went off and solved those problems. But I think the real world problems on spectrum sharing, they don't have any good solutions yet. And we struggle as, in the spectrum regulatory agency of how do you come up with rules? Because at the end of the day, there's this one camp that says that we don't need any rules. All spectrum should be available to everyone. We know that that's not going to work. You have to have some lanes within which you play. But even there are many, many, many outstanding questions. So for a simple thing like just use of the unlicensed bands, when LTE, raised the prospect of using systems like LTE-U or LAA in the unlicensed band, there was a huge pushback from the Wi-Fi community who kind of claimed unlicensed as the Wi-Fi spectrum. It isn't the Wi-Fi spectrum, it's unlicensed. And there really is no reason why the cellular or anybody else should not be able to use it. Having said that, it is also clear that when you share spectrum, whether it's unlicensed or whether it's like the CBRS kind of framework, you have to look at the problem natively. You can't just say, I have designed the system for operating in licensed, and I'm just going to make these little tweaks so that I can move it into the unlicensed band and satisfy the rules. That doesn't work. And so what we really need over here is, again, as I mentioned before, these two communities that govern our wireless experience to come together better, to really understand better how they can use each other's spectrum. And when I say that, it's mostly licensed, the cellular world using unlicensed. I hope there will be a world one day when the licensed spectrum will also be made available to other users, but given the billions of dollars that the carriers spend on their spectrum, I doubt we're going to see that anytime soon. 1.2 gigahertz of spectrum was made available in 6 gigahertz for unlicensed use. There's nothing stopping 5G NRU from deploying there, and I hope they do. But you have to spend the time and the research to really make sure that these systems do not step on each other's toes.
So a quick comment from an outsider. First of all, it reminds me of the crying wolf stories for little kids. Don't cry wolf too many times because then you're not going to be believed. What spectrum shortage? Just to be a little provocative. We don't have a problem with spectrum shortage. We have spectrum hoarders. And as the public agencies have discovered that spectrum is money, all of a sudden there is spectrum coming from every single direction. So we have 3.5, we have 28, we have here, there, and everywhere. We have a flood of spectrum. It's just poorly utilized. So number one is just proper allocation of what we have. And I think we have spectrum for years to come. And then, of course, very simple. If the Wi-Fi has shown that it's incredibly successful. If you keep your power levels low, then you can coexist to a great extent. Yes, if you are super dense apartment building and you can see 24 SSIDs, yes, you have a problem. But cellular wide area is interference limited. So it has to manage interference in a predictable way. So maybe it makes sense to be licensed there. But even my point at the beginning, I think I want to just finish with that. Do we even have a spectrum shortage, or we just have spectrum hoarders?
Any response to that?
Well,
yeah, if I may step in, I get your point, Ronaldo. Let me put it this way. It is legacy spectrum users, for example, broadcast television. Who watches broadcast TV today over the air? Should we even be thinking about continuing to reserve a very, very useful part of the spectrum for TV? And I still have wounds from the TV white spaces days where we tried to come up with ways to use just the white spaces in TV, and that was a problem. I think the key is whenever we are talking about spectrum that already has an incumbent in there, right? So for 3.45 gigahertz, is to, I don't think it does any good, and I'm going to put my regulator hat, which I don't wear anymore, on for a minute. It doesn't do any good to come in and say, your application is outdated and you don't need the spectrum anymore, give it to us, we'll make better use of it. I think a much better approach is to say that, look, I understand your application, you're using it in 5 areas of the country, and you are not using it in the rest of the country. Can we figure out a way where we can use it where you're not using it? And that is really the heart of dynamic spectrum management. Yes, and if you were to do that, fully agree that there is enough spectrum to go out. The challenge though, and this goes back to the needs of future communications, is more and more we are seeing the wide bandwidths matter. So having the 100 megahertz channels helps you a lot in getting these throughputs across. You may not be able to find all 100 megahertz contiguously. And honestly, from what I've seen of how 4G and LTE has advanced in carrier aggregation, that doesn't seem to be a big bottleneck anymore. You can aggregate bits and pieces of spectrum where you find them to create this channel that serves the end user very well. So your example of high power outdoor and lower power Wi-Fi, perfect. Is so if you're in, and we've seen this in the LAA deployments in Chicago, is yes, you have your primary carrier, which is licensed, which is long range, which is high power. But then if you're in an area where there's a lot of unlicensed channels available, just aggregate them onto your primary carrier. And then suddenly you have 80 megahertz of bandwidth, and you didn't have to pay for the extra 60 megahertz you got from unlicensed. So these are the innovations, I think, in spectrum usage that will make sure that we don't run out of spectrum. And I don't think we will. I honestly don't think that is the big problem we are facing.
So John, you had something to say. Thank you, Manisha.
So taking off my university hat, put my other hat on. The company I work for actually collects data. It's the largest database in the world on broadband access, Wi-Fi and fiber, copper connections. And we reported there's a group that's called the Dynamic Spectrum Alliance, which is basically a lobbying group, and they contracted us to use that data. We had to anonymize it and get away with all privacy, but we solved all those problems. And the group that the names are important. It's Microsoft, Amazon, Facebook, and Google are the founding members of that. So you kind of get an idea which side of this battle it's on. But the Wi-Fi spectrum, Ronaldo, it is good, and kudos to the FCC in the United States. That has not happened in Europe yet on the 6 gigahertz band, but the data indicates, and this is a hard concept for maybe more academic type communication people to understand, but you reach a threshold of cost when your users start, and when you start to get just a few % of the customers in serious trouble, the costs go way up for whoever's providing the service, the internet service. And once you, and we did cross that threshold in the United States last year in the 5 gigahertz band. And so the costs were going to go way up. Europe is running about 12 months behind the United States on that, but it's the same trend. You can see very clearly it's happening. So at least the Wi-Fi bands, they needed the extra spectrum. Now, could we be a lot more efficient even with unlicensed spectrum? I like to call this, and so Monisha, take your hat off for the FCC. I call it the artificially intelligent regulator. And it kind of implies putting a robot, in the, I give a talk where I have the FCC 5 commissioners sitting there, and the one in the middle, which is the chair person, has a robot on top of the face of the FCC, implying that artificial intelligence and other things may be the solutions to the more efficient use of the spectrum. So I agree that it could be used a whole lot better, and then maybe we don't need as much spectrum. But the way of regulating spectrum with the calls for information and other things, it takes years, and there's political groups fighting in that. If that can morph into something that is less people-oriented and more, automated policy oriented, they could be more fair, and if it might be 10 to 20 years away from that. But then we would get a more efficient use, and it might be that spectrum eventually saturates, but we have more than we thought because we're using it better, which is your point, Ronaldo. So do we need people making those decisions, or in the future, should that morph, like a lot of other things, into a more artificially intelligent, policy imposition on all spectrum, or at least some segments of spectrum?
To your point, John, I thought that after the catastrophic failure of cognitive radios, the industry had wised up and moved on to what I advocated way back to Preston Marshall and all that crowd way back, which is the spectrum management. So I see no reason why you could not have a super dynamic, you deep into a database, you declare how much power you're going to transmit and your coordinates. And if that bandwidth is not in use within a certain geographical area of your declared site, and I love the nuances of propagation, believe me, that's my entire career. But to a great extent, you can draw a circle and do and withdraw the token. And
Mhm.
then that spectrum is occupied until you return the token. And today's technology, why could not that happen at a second dynamics? And just doing that over increasingly larger areas of spectrum would achieve, I think, what John is saying. And it's a matter of politics, because I think the technologies are all there. I know it's a viable way of doing it, and I know Spectrum Server is a function that is being assigned or even commercially available, but this could be done much more intensively over much wider pieces of spectrum as well as geographical areas. Yes, Manisha.
And that's happening. So CBRS is doing that, right? However, I really don't feel that we should be dividing the world into database spectrum management and cognitive radios based on sensing. I really think the two should be together. And CBRS kind of did that, right? They have an environmental sensing capability that feeds into the database that then decides, what channels are available. But going to a point of propagation, and you're the propagation guru, right? The biggest problem that has happened with this is that propagation models for all of these bands are 50 plus years old. And the exclusion zones that these databases are putting out are so huge that they're actually, they're not helping. And
well,
so
maybe they should be challenged.
Yes, I think that's a challenge. So those are kind of the future areas of research, whereby how do you, very quickly have measurements on the ground reflect in your propagation contours that you're doing at your database. So it's a very tightly coupled management system. And again, the technologies for doing this are not revolutionary. They exist. A lot of it is a matter of will. It's a matter of incumbents not wanting this kind of a technology because it's too dynamic and they don't have any guarantees about when interference will and will not occur. But having said that, I think that is one method. I don't think that's a method that fits everywhere because of cost reasons. So going back to what you said, John, about Wi-Fi, 5 gigahertz being saturated with Wi-Fi, there is a huge bunch of Uni2 spectrum, which is woefully underutilized. And that's because device manufacturers did not want to put that little extra cost that they need to put in to implement DFS, right? So there is a give and take. So on the one hand, when spectrum is made available on a shared basis, and there is a little bit of cost associated with making sure that you put in the bells and whistles that you require to make use of the spectrum, and device manufacturers just don't want to do it, that's not very efficient use of spectrum.
Oh yeah, I think you're right about the device manufacturers, and it's a cost issue for them on the DFS. And yes, that changes some of the 5 gigahertz results. I've seen that effect. You're correct. I think the point I was trying to make was a broader one, because you and Ronaldo kind of went to these methods specifically, and there's a difference between engineer designed goals and principles and ones that are learned from the customer base itself. Mm-hmm. So artificial intelligence can do if you know the difference between quality of experience and quality of service. Engineers tend to think of quality of service, packet error rates, that kind of stuff. Right. Whereas quality of experience is where they're putting their hand up because they're angry. Their service doesn't work, and you can train to that. So that's where the artificial intelligence comes into this, is doing that. And I can give you, sorry to pick on the FCC, and I didn't tell this to
Monisha. I'm not with the FCC anymore, so you can pick on them as much as you want.
Other FCC commissioners and CTOs and chairmen in the past. The current method that they use of 80% of the customers get 80% of the data rate, 80% of the time. There's no telco in the world that complains about that, because you're giving them a free pass. Mm-hmm. That's not where the cost threshold is. When you get 95, 95, 95 or numbers above that, now you're talking about the real costs. But giving someone a pass on that criterion is not the right criterion. It doesn't involve quality of experience. It's an arbitrary rule that someone came up with, and we've been doing it in the FCC reports for a decade now. And it annoys me every time I see it, because it has nothing to do with the end consumer experience. But that's how we grade our broadband and how we we spend money in the United States and how we solve the problems. There are better methods, but they will need to become intelligent and based on consumer reaction. Consumer means consumers of the broadband itself. And that's why I said it might take 10 to 20 years, but the technologies are starting to merge where that can become possible. And then the efficiencies that we'd all like to see could indeed happen.
So if I may pick up, John, a little bit on the data angle, I am absolutely a big believer on the importance of machine learning and AI for the future of communications, which is again the topic of the panel. So let me ask you this. Are you willing to share the data that your company has collected with the researchers who I'm sure listening in would love to get their hands on some real world data that they can use to drive their research?
There are efforts to try to do that. The only issues, as you might guess, is you can't give away private data. So you have to anonymize it and aggregate it in ways, and you can't compromise the data that a service provider may own. And they don't want that data, somehow being reflected back negatively on them. So you have to solve that problem. But there are ways to do that. And the bigger the database that you get, the more sources of data that come into it, the more anonymous it becomes. And then it becomes useful for regulators and the industry and the consumer to begin to make better objective decisions, because the biases of the individual vested interests, don't enter into it. So it's a good goal to set. But, there are many steps getting there, but I believe that ultimately that is soluble and would be a big improvement. And I think we'll get there. It's just a matter, sometimes we technologists, we tend to call it too early. We say, okay, I think we can solve all these problems, and so it will happen. And it takes twice or three times longer than we thought to actually get there. But I think there is a way there.
Okay. All right, well, I'm going to change gears slightly and ask you all, if you were a young engineer starting out now that you're not young, John and I are the same age, so I can say this. What would you start working on? What would you want to go into? Who wants to start there? We've got
wireless, no question, wireless. As I've said for years, you can always lay down more optical fiber. You can never lay down more spectrum.
Manisha?
Yeah, I think, now that and maybe Tom, you're aware of this too, but I think EE departments in universities across the US are really hurting for the good students. Everybody wants to be a data scientist today. And it is really, really hard to tell people the excitement of what you can do with wireless is. And honestly, starting from the antennas to the devices, to the front ends, to the actual physical layer, MAC layer protocols, to AI, which is the newest kid on the block, the opportunities are huge. And I really, really wish that many more of the bright students that we're losing to data science would come back to wireless. Depending on what it is you want to do, there are many places along the stack where you can find something that interests you. So definitely, yeah, wireless is still one of the most interesting fields to be in EE.
Okay.
So quick comment, and it's not opposing the previous ones, because it's wireless, it's AI, ML, it's all of those things, but targeted towards cyber physical. I think that's a combination that is about to explode. We've all seen a little bit of it when we see these robots that do amazing things for almost 10 years now. We've seen these robots doing incredible things. We've seen drones. So we've been teased here and there on how super intense software-driven machines are interacting in the real physical world. So the interactions of these two, I think, is going to impact society in untold ways. So if I was young, I would want to be part of that cyber physical building the new world.
And John, do you have anything to add to that?
Well, anyone who's worked in a university for a appreciable period of time, I threatened to put a couch in my office and charge several $100s an hour, because I think I'm more psychiatrist than anything else. The students come into the office with their various, issues, but many of them are troubled about, what area should they go into and what should they do and all that. And I typically answer that question and say, well, do you like it? What area do you really like?
Yeah.
Instead of telling me, well, how much money can I make in this versus that? And that's, do you like it? And if you like it, you tend to be good at it. That's probably why you liked it in the first place. And that's what you should go with, because a lot of things are going to change over the course of your career. Things will go up and down, but you should do what you really like. And if you're really good at it, is going to be a way for you to add contributions, and you're going to be happy doing what you like. So as far as the communications field, I really like it. I love being into it. And if somebody feels that way, I don't care what color, sex, creed, or geography, or that you want to work in that area, you should go for it and do it. But you should go with what you're good at and what you like. And fortunately, because of maybe geopolitical forces that are well beyond any of our control here, we now have this huge amount of money and companies. I can't say a lot here, but some of the biggest companies in the world right now, the $1 trillion value companies, have these huge secret efforts with hundreds of engineers starting to work on physical layer again, because of the security threats that have been perceived and the rewards and benefits that they may receive. So that may be good, and it'll give us another positive round the next 10, 15 years, another jolt for communications. But do it if you like it and you're good at it, and whatever that is, even if it's AI and machine learning or something else that's going on. But if you don't like that stuff, you want to do something else, you should go with what you like, and not so much any one specific area is good or bad, because that's an individual decision.
Okay. All right. So I'm going to change gears again. And so the question actually is, users are accustomed to more and more data for the same revenue per user. So it's been flat over the last 5 years. Can this continue indefinitely, or what's going to have to change? Ronaldo, do you want to take that one?
Yeah, well,
You wrote that question.
Up to that question. To me, that's the biggest challenge we're facing in the classical cellular industry. It's sort of, we do a cognitive dissonance game. We have this great story about 5G, 6G, but we know in private that revenue per user has been flat since 4G era. And so so far, the advantages of microelectronics has allowed the equipment vendors and the service providers to exist in an industry where their product is being devalued month by month, because they're delivering more and more of it for the same total revenue. I think this doesn't bode well for the future of this industry. Now, I think we may be to be more optimistic and positive, we may be at a critical point of departure, where we leave umbrella, wider networks good enough, and they will continue with their organic growth, in throughput or revenue as it may be. But we move a completely different area, different deployment scenarios, different applications, whether it's factory automation or indoors mixing of, through augmented reality, cyber physical, et cetera, et cetera. All I can imagine is that there is a yet to be invented new world. And let's hope it's a very brilliant and thriving, both economic, because economics, it underlies everything we do, and also a quality of life. But business as usual, it's going to get us in trouble.
Any other thoughts on that?
Yeah, I think one of the biggest things that at least I hope to see that comes out once 5G becomes mature and deployed is that we will have new applications beyond just consumer wireless. That is not going to be the only thing that these cellular systems and standards and networks are good for. And we're already seeing that happen with CBRS. The universities are, there are companies that are coming into universities and offering to deploy CBRS networks, which would be kind of not necessarily replacing Wi-Fi, but augmenting the offerings that a university campus does with Wi-Fi with CBRS. So maybe offloading a lot of the campus camera infrastructure onto a different network. So these are different use cases that are already beginning to emerge, and it has come out with a combination of things. It's not just 5G, because there's nothing inherently about 5G technology that enables this to happen. It is the availability of spectrum like CBRS, which is not as expensive as the truly licensed spectrum. And so the business model has to evolve. If I think Reinaldo is probably in a much better position to comment on, the revenue per user is not going to grow. And if that is the only thing that drives innovation in wireless networks for the future, I think we will face a problem. But I don't think that that will be the only way that revenue will grow. There will be other applications that come up.
Okay, there's a question from the audience from I'm going to mess up the name again, Massimiliano. I think one of the future directions is integrating communication systems with natural systems for applications such as body area networks, sensors, and biological fields. Is wireless always the way to go in that case?
Well, I think the question underlies a much bigger question with the redundancy. Are those applications that involve such short ranges like body area networks part of the scope that we're discussing here? Because to me, it's a completely different set of players. Maybe it's the fashion industry, absolutely consumer. So a different set of players for the equipment, quote unquote equipment or devices. This is consumer electronic, this is fashion, this is apparel or health. Is this related to, just to sound very dinosaur, 3GPP cellular wide area networks?
So having actually worked on medical body area networks in a past life, I think the relationship, yes, as these are much smaller applications, but they leverage what's available in these other networks. So for example, yes, somebody can go off and design a medical body area network that is purpose built for that purpose, but the economies of scale are not there if you have to build a whole new set of devices and networks. And so when we were doing this back in Philips, we wanted to leverage Wi-Fi. We wanted to leverage the Wi-Fi standard, the Wi-Fi devices, but perhaps in a different spectrum. I think this is a future direction. I don't know if this will be a driving direction for everything else. I think they will leverage from developments that happen in the broader wireless space of cellular and Wi-Fi. I've worked on wireless underground sensor networks where you throw little radios under the soil. I don't think custom building a device for that application makes sense. You want to be able to leverage what's already out there. And I don't think 3GPP is going to design their network around supporting an application like that either. So these applications are important, but I don't see them driving the direction that these major standards and device manufacturers take.
Okay, so that leads into 6G. As we all know, every time there's a new standard, we always go to the next one. People start, I remember when 3G was, everybody started talking about 4G. So now we're about 6G. So one of the questions I know that Ronaldo was talking about was energy frugality. So what aspects of 6G, if you were making a list of desires, what would you want in addition to energy frugality or anything else? And if you can comment on that point.
Yeah, two cents, and this is really a departure from up to now. Up to now, we've been happy-go-lucky, essentially on the path that we were before. I honestly think we are at a threshold of fighting for the survival of the species. It's that dramatic. That's it. That's it. That's simple. And if you really embrace that, then we need to really think again. Every chart I see, the more antennas, the more power it drains from the outlet. It's not sustainable. So I think physical layer has a huge debt and a huge challenge to reinvent itself and contribute towards the survival of the species. whether by making base stations more efficient, whether by making applications that impact other industries, et cetera, et cetera. But we cannot go on literally as we have so far.
Any comments on that? Well, I remember when I was a grad student, we were always taught to conserve energy when we design a system, but you're talking about going beyond that. Sort of the most bang for the least energy.
Well, I think we need to rethink from very fundamentally the way we live.
Yeah, no, I agree. I think that's a very important point. Okay.
Yeah, so if
Yeah.
I may, I
Of
think
course.
moving away from the question of energy for 6G and the broader question of why does the cellular industry keep moving from 1G to the next?
Yes.
And more importantly, why does it keep asking for new spectrum every time it moves into a new G, right?
Yes.
There is, I think, a fundamental switch that needs to happen where we try to think about a system, whatever the next system beyond 5G is something that is constantly evolving, one that does not need to constantly have new spectrum allocated for it, obsoleting previous systems, because it is very inefficient when you look at this process that the cellular industry has adopted. So for example, 3G networks are going to be discontinued very soon. There is a whole set of users that the network providers, I don't think, care about, which are people who've deployed sensor networks based on 3G because they were very power efficient. They were really very, very power efficient. For if you were design, there are people who've designed buildings with sensors embedded in the walls that are working on 3G. And suddenly, with that 3G network gone, that whole infrastructure, that whole deployment becomes useless, right? So I really think that we cannot afford to keep doing this in wireless. Now we are at a stage, we're mature, we all expect certain things from wireless. And again, not to sort of belabor the point too much, but Wi-Fi, for other hand, I think does a much better job of being backward compatible. Yes, you lose some efficiency in the process by constantly being able to support devices that are older standard, but that there is a natural progression of how you stop supporting a device. You just don't turn off a network and a frequency and just let those people go. So as we think about 6G, and by the way, I'm sure all of you have heard the notion that only the even Gs have been successful. The odd Gs are just a stepping stone. So with the odd Gs, we really figure out what was wrong with the previous even G, and then we wait for the next even G to actually put it into implementation. So maybe with 6G or whatever comes after 5G, we really stop and think about how we think about evolving this, because from the spectrum point of view, we cannot keep having spectrum for 3G, for 4G, for 5G, for 6G, and we wait 40 years before we relinquish spectrum that was allocated to 1G. And from the application point of view, is if you're designing a sensor network with batteries that last 15 years and the network is not there in 10 years, what use is that? So there has to be a much better holistic view of the path forward as we're looking at the future of wireless.
Anyone else want to jump in on that one? Okay.
I'm not sure that, yeah, Manisha has made a case for why back compatibility is a good thing, but sometimes it can hinder things.
Yep.
Certainly, 5G is supposed to be in part about massive MIMO, but most of the deployments in the United States are still these FDD things, and I don't think too many serious researchers really believe FDD massive MIMO could ever be as effective as TDD. This is entirely a legacy thing. In fact, perhaps the opposite should be done. I think that this 10-year cycle on new generations of wireless, if you think about it, is actually pretty slow. I mean, people somehow think that new technology comes along at a lightning-like speed, but 10 years is an awful long time. And in part, is this due to that the rules on depreciation of equipment are such that it encourages 10 years. I think we need the opposite, more rapid innovation.
And that's why we need the next G to constantly evolve. We don't draw a line. But I wanted to address something that you brought up, which is actually one of my biggest concerns right now. Is so most 5G spectrum is TDD. It's not FDD, and so it will play into the deployment of massive MIMO much better than FDD spectrum was. However, and this again goes back to the point I made earlier, that it cannot be only about the physical layer. From the physical layer perspective, TDD spectrum is much better for massive MIMO. But we are running into this issue with TDD where now you have one of the biggest advantages of TDD is the fact that you can do a very flexible uplink downlink split. But now when you have TDD systems being deployed across the 3 gigahertz band with varying power, you have CBRS, which is low power, you have C-band, which is higher power, 3.45, which is higher power. They're all deploying TDD. Can these systems actually create their own TDD splits without causing interference to each other because of uplink, downlink happening at the same time? So it does bring up other problems. It has solved the massive MIMO channel, identification problem with TDD, but it has brought up other problems that we also need to pay attention to. And that is why having the bigger view as to how your little physical layer advance is going to affect the end-to-end system is very important.
Okay, I have another question about asymmetry of data, and then we'll start wrapping up, which is great. So asymmetry of data, most of the data these days, I still think it's still true, comes from in the downlink to the home rather than the home to the uplink. But as more and more people become producers, do you think that will change the design of the system?
Well, quick answer. I think it's very dangerous to do social studies with a sample size of 1. But by far, I think typical consumers, us in our household, we consume incredible, extravagant amounts of data because of streaming. So the entertainment industry is putting out such a good offer of things to enjoy that I cannot see anytime soon the uplink becoming even a small fraction of what we consume downstream. And I think that applies to the consumer entertainment with a big broad brush. Yes, there are here and there the influencers and the like, but I think they're in the minority. So until we have a dramatic change on use case, I don't see asymmetry going away.
Anyone else want to comment on that?
Well, again, if you think that sometime in the future we will have things like ubiquitous augmented reality, that young people nowadays, of course, go around with their face buried in a handset, that someday they'll be wearing some sort of unobtrusive augmented reality helmet or device at all times, constantly wanting to share their immediate experience with comrades thousands of kilometers away. That will give you much more symmetric traffic.
Well, I defer. I think there's a lot of augmented reality that has not been explored that is still asymmetric, in that I want to see the teacher, I want to see the tutor, I want to see the manual, I want to explore the database. I don't want to be seen while I'm doing that.
But I think we've all had the experience of designing for systems that don't exist yet. Is that correct? I mean, when John, correct me if I'm wrong, but I remember when you all were working on DSL in the late 80s, early 90s, nobody knew a good application for it. Is that right?
Well, there was one or two, actually. There was a guy at the old General Telephone, like it's part of Verizon today, their CTO, guy named Bob Olshansky, who did actually anticipate the internet thing. I mean, the internet already existed at that point, but he did comment. He said, look, your symmetry ratio needs to be 8:1 because that's what the acknowledgement packet protocol needs in TCP. The telcos were pushing like 100:1 ratio because of the video argument. that we just heard. And so I said, okay, got his support to do things. And I designed 8:1 into the standard at that point, and it's stock, but it has shifted more to 4:1 in some of the more recent broadband access standards, although of course the GPONs are kind of symmetric in a sense. The data rate is the same, although how you handle the multiple access version versus the broadcast version downlink may be different. But asymmetry has been lessening. Yeah, I think there's a famous movie, The Field of Dreams, right? And now there's even a major baseball game every year on it. If you build it, they will come. Businessmen hate that, but it's been true in the communications industry, at least over the entire time I've been employed in it. The network and capabilities typically has preceded the killer applications that then became better understood because they had that bandwidth, the creativity of all those people out there in the ends of the network, found ways to use it. So if you build it, they'll come.
Yeah, and I think I agree that the consumer demand will, in my mind, will always stay asymmetrical. But the new applications, factory floor automation, sensor networks, where you have a lot more, and the sensors are not like little 1-bit sensors. These are cameras as sensors, and they're putting their video back on, will stress the uplink. And in my mind, again, having a flexible uplink downlink split in a network just makes sense. That way you tailor the network according to your needs. In most cases, maybe it is mostly downlink, but should you want to, you should be able to, have more uplink traffic at the expense of downlink traffic if you should want to do that.
Yeah, I don't want to get too technical here, but I understand the asymmetry in terms of throughput, but asymmetry in terms of the air interface, as in having TDD with adaptive fractions of up and down, and at the same time have multiple service providers not coordinated. I think it sets up this disaster of having
That's a problem.
shooting into each other at the same time. I don't know how you solve that problem.
That is actually, if anybody is looking for a real tough challenge to solve, that is a good one. I think it's a really, really hard problem. And if you look at some of the FCC and PRMs, when I was at the FCC, we recognized this, and there were calls for the FCC to regulate TDD synchronization across the band. FCC didn't want to do that. They've left it up to industry to figure out how to do this. But this is a wide open problem from the research point of view, from an implementation point of view, as to how do you do this efficiently.
Okay, so with that, are there any last questions from the audience? You can type them into the chat. Don't see anything popping up. So I think, even though I said we're going to one, that was sort of a wiggle room. It was really a 90-minute presentation. I want to thank all our speakers for today, because I learned a lot and I enjoyed it. So I want to thank John, Monisha, Tom, and Ronaldo. Any last thoughts before we sign out?
Long live communications.
Yay. It's been a revival meeting. We've revived communications. Anything else?
Plenty of fun stuff to do, and thank you again for inviting me, and it was a pleasure, and stay well and be healthy.
Okay, anyone else? All right, well, with that, and if no one else has anything to say, I think I'm going to start my video and say thank you all for coming. We're going to have another panel in a month. Stay tuned. I will be sending all of you email with all the information. We will have Ana Garcia Armada, Angel Lozano, Ted Rappaport, and now I'm blanking on the fourth person, which is really embarrassing because it's a really good fourth person. But you will have to have a moment of suspense and stay tuned to the email I will be sending to all of you who participated, including a survey on what we're doing and what we can do in the future. Okay.
Thank you, Katie.
Thank you so much. So with that, I'm going to say bye-bye and hope to see you in the near future. Bye.